Okay, so I'm going to open up a web browser from PC1 to the server. The server's IP address, and this is a Linux server, is 10.1.1.100. I used the command ifconfig to see the server's IP address. So what I'll do is start capturing traffic between the PC and the switch. GNS3 makes this very easy. It allows us to capture traffic directly within the topology, rather than having to install a hub or a wiretap or something to see the traffic. So I'm going to capture the traffic between the PC and the switch, and we'll be able to see exactly what's going on within this Wireshark capture. So you can see that we've got spanning tree traffic, we've got EIGRP traffic, dynamic trunk protocol traffic already displayed and being captured by a Wireshark. What I'm going to do, however, is filter for HTTP. There's no HTTP traffic at the moment. But what we'll do is open up a web browser on the PC and connect to the server. So let's use PC1. Open up a web browser. I'm going to browse to 10.1.1.100, which is the server, and as you can see there, a web page is displayed. Now it's nothing fancy, it's just a basic web page hosted on this server, but it's enough for us to see what's going on. So in Wireshark, you can see that traffic was sent from a source IP address 10.1.1.1 to a destination IP address of 10.1.1.100. This is HTTP traffic. You can see the protocol there is HTTP. You can see the length. You can see that it's an HTTP GET. In other words, the PC is trying to get a web page from the server. Now, before I go through the Wireshark capture in more detail, let's explain some of the basics that you see in Wireshark. The first thing you see is a frame. Now, in networking, this is known as layer 2 of the OSI model. Information captured here are known as frames. So this is known as a frame. We've captured an Ethernet 2 frame. In other words, we've captured traffic on Ethernet. There are different types of Ethernet frames, but Ethernet 2 is the most common. The source MAC address is a VMware host. Destination MAC address is this. So the source MAC address is the PC. This PC is actually running inside of VMware. If I type ipconfig/all, you'll be able to see the MAC address of the host 000C29 ending in DC-D7. And hopefully that's what we see over here. So notice MAC address is DC-D7. So notice this MAC address is the MAC address of the PC. Destination address is this. That's the MAC address of the server. Notice the MAC address over here, 36E45C4091A2. There you go. That's the IP address of the server, MAC address of the server. Here's the IP address of the PC and the MAC address of the PC. So in networking, we use the term frame at layer 2. You get different types of frames. On Ethernet, typically Ethernet 2, but on a WAN connection or wide area network connection, you could be using something like point-to-point protocol or PPP or HDLC, or in the old days, you had encapsulations like frame relay or ATM. In other words, the layer 2 frame changes depending on the physical technology that you're using. Most common technology today is Ethernet. Most common Ethernet frame type is Ethernet 2. So this is known as a frame. Now, just to make it more confusing, in Wireshark, they talk about frames here as well. But this is actually just metadata used within Wireshark that tells us about the frame. So again, this is just metadata. We don't typically talk about that as a frame in networking. This is known as a frame. This is known as layer 2 in the OSI model. Now, I've included a section following this video that talks about OSI and the OSI model. So if you're not used to the OSI model or you're not quite sure what it's about, have a look at those videos. If you know about the OSI model, then skip those videos. And again, if you want more information, have a look at my CCNA course. So this is a frame. At layer 3, we have what's called a packet. So when we refer to the layers in the OSI model, we use terms such as frame at layer 2, packet at layer 3, and segment at layer 4. At layer 3, we've captured the IP version 4 addresses. So this is IP version 4 information. The protocol used here at layer 4 is IP version 4. What I'll do actually at this point is stop my Wireshark capture so that the capture that I share with you isn't too big. And I'll save this as basic Wireshark capture 1. Notice it's a PCAP NG file, or PCAP next generation Wireshark file. So that's the file that you'll download, and you'll be able to do something similar to what I've done here. So again, protocol at layer 3 is IP version 4. Source IP address is this, destination IP address is this. IP version 4 contains a lot of information. Differentiated services code points, or differentiated services field, DSCP, differentiated services code points, is to do with quality of service. Quality of service, or QoS or QoS, allows us to differentiate some traffic types from others. So in other words, we could say that voice traffic is more important than FTP traffic. So when you make a voice call, it should be prioritized over file transfer protocol or FTP traffic. This is a way to indicate to the network how important the traffic is. A lot of other information is shown in this header, including as an example that the protocol used at layer 4 is TCP. So at layer 4, once again, this is layer 2, frame, layer 3 is packet, layer 4 is segment. At layer 4, in the OSI model, we are using TCP here, and you can see source and destination port numbers. HTTP, or Hypertext Transfer Protocol, uses the well-known port number of 80. The server was listening on port 80. That's why when the client made a connection to the server, the web page displayed. The client initiated a session to port 80. The server was listening on port 80. It served, because it's a server, it served a web page to the client, in this case using the protocol HTTP. So it basically has this page, this web page hosted on its hard drive, and it served that page to the client when the client connected on port 80. The client uses this random port number, or ephemeral port number to use the correct term. So it connects to the server using an ephemeral or random port number going to a well-known port number of 80. And then you can see here, the application used is Hypertext Transfer Protocol. Now, in networking, we talk about the OSI model, but typically it's a hybrid model between the TCP model and the OSI model. At the top of the OSI model, we have application, presentation, and session. Those layers are often grouped into a single layer called application. So notice we have layer 2 here. Layer 1 is the physical medium. So that's not shown in the Wireshark capture. The physical medium here is Ethernet, could be copper or could be fiber. In our example, this is just a virtual network, but in the real world, this would be physical Ethernet. In this case, perhaps copper. So the physical media is copper. So that's the physical connection. Here it's just a virtual logical connection. So layer 1, physical. Layer 2, data link, or in this case it's Ethernet. Layer 3 is network. In this case we've got IP. Layer 4 is transport. In this case it's TCP. And then the top 3 layers are kind of combined into one layer, application layer. So notice Hypertext Transfer Protocol. And inside here we can see details such as the client used. It shows up still as Windows NT 10, Win64-bit, using a browser, Mozilla 5.0. So in this example, I'm actually using Microsoft Edge. That's the browser used within Windows 10. So this is a Windows 10 virtual computer. In other words, it's virtualized. I'm actually running on a Mac here, recording on a Mac. But I'm running VMware, which allows me to virtualize multiple devices within my GNS3 topology. So the Wireshark capture sees the client as a Windows 10 computer, which is correct. It's using 64-bit Windows. Mozilla is the browser. It's actually Microsoft Edge. and then the server replies back. Notice in the server example, the MAC addresses are swapped round. In this example, I've got a layer 2 switch. A layer 2 switch means that it's just simply switching frames, in other words, layer 2 data from one port to another. It's not trying to route the data from one network to another. These two hosts are in the same subnet or the same network. So the switch is simply switching the traffic from one port to another. So in this example, the IP addresses are swapped around, and so are the MAC addresses. Going back to the first example, notice source MAC address is this, destination MAC address is this. When the server replies, those are simply swapped around. So the server is replying with its MAC address as the source, destination MAC address is the Windows computer. IP addresses are swapped around, and so are port numbers. And if we look at the hypertext protocol, notice we can see server says 200 OK. 200 means that the server was able to provide the data to the client. We didn't have a 404 HTML error as an example. Some data was provided to the client. Notice you can see here the actual web page that was served to the client. So you can see it says Networkers Toolkit. You can see the PNG file. Notice Networkers Toolkit. And if I look at that web page on the client, notice you can see the output here. It says www files located at var www.html. And if we look here, that's actually what you see. Files located at var www.html. So if I scroll to the right, notice you see the full output. You get to root after logging in. Notice we told you can place files in TFTP boot, and that's exactly what you see over here. So Wireshark has read the HTTP traffic. Be careful with HTTP. It's clear text. So through Wireshark, you can see exactly what's going on. Here, the client is trying to get the PNG image. So it's trying to get the actual PNG image. And here the server, which is an Ubuntu server, is providing the PNG file. So that's the actual file. And you can actually export that. And I do this again in other videos, but let's do it right now. GNS3 image. So I'm going to export that to my desktop. And on my desktop, I'm going to change that to a PNG file. And then when I open it up, notice there's the actual image. So Wireshark captured all the data from the server as well as the image. And that's the image that we have on the server. So once again, to do that, click Portable Network Graphics because it's a PNG file. And then go Export Packet Bytes. Save it to your hard drive. So I'm going to save it once again as GNS3 image 2. And then I'm going to rename it. So it saved it as a bin file. I'm going to rename that as PNG because it's a PNG file. And then when I open it up, you can see that it's a PNG file and there's the actual image. So you can see here it's getting the fave icon, and then we're getting something HTTP 404 error, something not found. So something went wrong here. But the point is that you can read the actual HTTP traffic. And remember, because these devices are on the same subnet, all that happens is the MAC addresses are swapped around, IP addresses are swapped around, port numbers are swapped around during that communication. So source IP is host. Here source IP is the server. So when the server replies back, it's replying back from port 80 to the client. So that was a very basic example of using Wireshark to see what's going on in the network. Were you able to download the PCAP file? Were you able to open it up in Wireshark and actually do something similar to what I've done here? There's no better way to learn than to practically use Wireshark, capture frames, and see for yourself what's going on. I've made it a little bit more simple by giving you some PCAP files, but hopefully they mean something because you're using the actual files that I'm recording right now, rather than just some random file that you got off the internet. Now, please note, it means a lot to me if you provide feedback on the course. So if you're enjoying the video, then please say so. If you get prompted to leave a review and you're enjoying the course, then please do that, because it helps other students and it helps me make the course better. Let me know how I can improve the course as well.